So today I keep update my own algebraic geometry notes. So today what we want to prove is the Hilbert basis theorem. Okay, so what Hilbert basis theorem said is that if a ring, so the ring is commutative with identity, if ring is Noetherian, then R of X, the polynomial ring is Noetherian. Okay. This is the famous theorem in the commutative algebra. Basically, probably is the key to the algebraic geometry. So I want to prove it and make a recording. Okay, so what we need to show is that any ideal. So we want to show any ideal in R of X is finitely generated. Okay, I will use FG to shorthand. Okay, so this is what we want, and the proof is that suppose not. So we want to show. So now we want to show that if R of X is not Noetherian, then R is not Noetherian. Okay. Okay. So we take I in R of X, which is not finitely generated. Okay, because R of X is not Noetherian, so which I is non-zero, and I can take. I first take F1 belongs to I non-zero and with the smallest degree. So basically, since this ideal has basically the element in the ideal is a polynomial. So I just take the smallest degree. I take any one with the smallest degree. So which must exist, because the smallest degree must can be 0 or 1. But I already know which is bounded below. Okay, so I can take F1 with the smallest degree, and take F2, which is not generated by F1, and have the same properties. Basically, we take the F2 inside here with the smallest degree, and then we take F3. Basically, comes from the first one generated by, and the second keep doing. So we will have Fk. We will have a lot. We will have infinite Fk, k from 1 to 0, from infinity. Okay. So I can I let nk to be degree of Fk. Okay, this is just for convenience. Okay. And I take the leading coefficient. So basically, I let ak to be leading coefficient. Of Fk. So basically, the Fk look like this. Basically, is akx and k . So this is the definition. Okay, so I take the ideal general. So I have an ideal which is called a1. I take, and a1 is generated in a1, a2, a1, a2, a3. Keep going. So this is the ideal chain in R. So now I want to say that this chain is not stable. It's not stable. If I can show that, then I know that R is not Noetherian. Okay. So ideal chain R is not stable, means that does not exist k such that a1, a2, ak will equals to a1, a2 goes to ak plus 1. I want to show that there's no such k. And the reason is difficult. It's not so easy to see why there's no. Okay, so suppose there is it. Suppose there is then what? Then means ak plus 1 will fall into a1, a2 to ak. So that means ak plus 1. So there exists the bk, which in bi I from 1 to k in R, such that ak equals to b I equals 1 to k. Okay, so we must have this one. Okay, so what is the next step? Okay, so the next step is that how about that I let g equals to fk plus 1 minus bix ni plus 1 minus a minus nk and times so-called fi from I from 1 to k. Okay, so here comes the important point. So first one is that g is not in f1, f2 to fk, and the reason is that if g is, then because this is f1, so because this is the span of f1 from f and f2 to fk, and then fk plus 1 will be g plus this term. So then fk will become fk plus 1 will become f1, will falls into the ideal generated by this f1 to fk. Then so there's a contradiction. Okay, so g must not into this. Okay. Also, the degree of g. So degree of g means the degree of probably we don't care about degree of g, but we care about the leading coefficient of g. So leading. Okay, let me see. So how what I should say. Okay. So the degree of g. So basically, you see that the degree of fk plus 1 is nk plus 1. Oh, sorry, I forgot. This should be nk plus 1 minus ni. Then this term contains x nk plus 1, and this fi has degree ni. So all of so each term of this is the degree nk plus 1, and all this is also degree nk plus 1. So the degree of g is at most is nk plus 1, because this is nk plus 1, and each term is nk plus 1. However, the leading coefficient of nk plus 1, the leading coefficient of nk plus 1, which is ak plus 1, right? This is definition. The leading coefficient of fk plus 1 is ak plus 1, which is minus bi, and each term is ai. Each leading coefficient is ai. So, but this is our relation. So this is 0, which tell you that the degree of g must be less than nk plus 1. But this is a contradiction. Because if degree g is less than nk plus 1, that means f of k plus 1 must fall into the span of this, which is a contradiction. So there is so much contradiction here. But remember, so if this is contradiction, that means this cannot happen. This cannot happen. So this is wrong. So each of one must be strictly increased. Then we can show that the ideal chain in R is not stable, which tell you that R is there's the exist of this one, so the R is not Noetherian. Okay, so use it, then we already show that the original Hilbert basis theorem. So we prove it. OK， OK， 大概就是这样。所以这主要是我要证 Hilbert basis theorem 的一个论述。OK， 那大概就这样。Thanks for your watching, and if you like this video, please subscribe to my channel. I will see you guys in the next video.